Now let's solve the next question given in GATE 2007. Okay, so the reference string is 1 2 1 3 7 4 5 6 3 1. Okay, and the number of frames are 3 as usual. I don't know why they picked up this number 3. And now let's solve it with first optimal. Fine, 1 is not there, load it. 2 is not there, load it. 1 is there, leave it. 3 is not there, load it. 7 is not there, so we have to replace it. Now by optimal algorithm, it will try to look in the future and then it will see which one will not be used for a longest time. So if you look into the future, which one will not be used for a longer time, watch it. So see this 1. Okay, see this 1 and 3, they are actually used somewhere, but 2 is not used anywhere. Therefore the best one to replace is 2 because it is never used in the future, right? So we are going to replace it with 7. Got it? And next one is 4 is required. So if you look into the future, 1 and 3 are used but 7 is never used, therefore you replace 7. And next 5 is required. Now look into the future, 4 is never used, so you replace 4, right? And look, and again 6, so 5 is never used in the future, so replace 5. So what is it? 3 and 1 will remain there, and 3 will be referred present, 1 will be referred present. Are you observing this? Since 1 and 3 are used in the future, they are never going out of the main memory. I mean, we have the chance, whenever we have some other frame which is not used in the future, then we are going to conserve 3 and 1 by substituting the other one, right? Okay, now how many misses are there here? Page faults 1 2 3 4 5 6 7. So 7 misses out of how many? 1 2 3 4 5 6 7 8 9 10. So 70% is the miss rate. Got it? So in fact the miss rate is so much high because there are lots of pages referred. See, it is not that only few number of pages are referred, there are lots of pages referred. Actually, see, how many pages are referred? 1 2 3 4 5 6 7, right? So since there are 7 pages referred, at least there will be 7 page faults. Are you following it? Why? Because since it is a demand paging, pure demand paging, in order to get them at least once, we need 7 page faults, right? So this is not the mistake of the optimal algorithm. The program requires 7 pages, all of them at the same time, and then we don't have that much space. We have only 3 frames. That is why at least 7 page faults will be there. Are you following it? In a string of 10, 7 page references or new references, and for every new reference there will be 1 page fault, right? No algorithm can really help for that, not optimal or not any other algorithm. There is no way you can escape this 7. See, in any reference string, if the number of new references or unique references or at least n, then definitely there will be n page faults. Why? You cannot decrease it even by 1. If you want to decrease it even by 1, you should not be loading 1 page. But how is that possible? Got it? So since the new pages are 7, it is always there. So any other algorithm you use, it will definitely give you 7. Okay. Now let's look at the next one, which is LRU, least recently used. So initially 1 is referred, loaded, 2 is referred, loaded, 3 is referred, loaded. Okay, sorry. 1 is referred, not loaded, and 3 is referred, loaded, and 7 is referred. So now you have to look into the string and then you have to take the one which is not referred for a long time. So look into the past, right? So you want 7, right? But then 7 is not there. If you look into the past, so which one is the least recently used? So 3 is most recently used, 1 is next most recently used, and 2 is the least recently used. Therefore 2 will be replaced with 7. Understood this? And next 4 is required. So which one are you going to replace? 7 is recently used, 3 is next most recently used, 1 is the least recently used. Therefore 1 will be replaced with 4. It is a mistake, isn't it? Because 1 will be referred again, but you have replaced it. But in case of optimal has even conserved 1 because it was required later, right? Okay, anyway, algorithm is fine. We are following the algorithm. Algorithm is doing right, but conceptually you should not have done it if it wants less number of page faults. But then this algorithm works that in the other way, right? Okay, now 5 is required, 4 is most recently used, 7 is most recently used, 3 is least recently used, therefore it will be replaced with 5. And next 6 is required, So 5 is most recently used, 4 is most recently used, and 7 is most recently used. Therefore 3 has to be, okay, sorry, 7 has to be replaced. And next 3 is required. So 6 is most recently used, 5 is most recently used, 4 is most recently used. Therefore 4 has to be replaced with 3. And next 1 is required. So 3 is most recently used, 6 is, and 5 is the least recently used. Therefore 5 will be replaced with 1. So if you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So LRU is producing 9 misses out of 10. Therefore the page fault rate is 9 out of 10. So anyway 7 has to be there, and it is even producing 2. So the main advantage that Optimal did here is, for 7 new requests, 7 page faults have to be there, but it tried to see that at least the last 2 references of 1 and 3, they are going to be hit, not a miss, right? Okay, and next one is first in first out. Let's talk about first in first out, FIFO, right? So now we shall even maintain a queue. So 1 is required, 1 is loaded, 2 is required, 2 is loaded, and 1 is required, 1 is already there. And what about 3? 3 is required, right? So 3 is loaded, and no page replacement has happened. So in the queue, 1 arrived first, then 2, then 3, and next we want 7, right? So what is that we are going to load if you want 7? What is that we are going to replace? So the first one which has come has to go out. Therefore 1 will be replaced with 7, and next 4, right? So 7, and next 4, right? So which one has to be replaced? 2 has to go out, right? Therefore 2 has to be replaced with 4. Okay, and next 5. Now which one are you going to replace? 3 has to be replaced. 3 has to be replaced, and 5 will enter. And next 6, which one will be replaced? 7 will be replaced. 7 will be replaced, and 6 will enter, isn't it? 7 will be replaced and 6 will enter. And next one, which one has to be replaced next? Next we need 3. Which one has to be replaced? 4 has to be replaced. Therefore 4 is replaced with 3, and here 4 is 4. And next one is 1. So which one will be replaced? 5 has to be replaced. 5 has to be replaced with 1, and then 1. So if you observe it, even FIFO is also going to give you 9, right? So even FIFO failed to conserve the 2 spaces, right? Because FIFO didn't see that 1 and 3 will be required later. Only algorithm which was able to see that 1 and 3 will be required later is Optimal, right? So minimum is 7 because there are 7 new requests. But then Optimal has done one intelligent thing. It has looked into the future, and then it tried to conserve 1 and 3. But since these 2 algorithms cannot look into the future, they obviously failed. And anyway, no practical algorithm can look into the future. See, if you can look into the future and know the future well, we'll definitely take the right decisions, isn't it? So sometimes I wish that even life has this GPS. Like if someone tells us, okay, you go and join there and learn this thing, and you go and join there, learn this thing, read this book, and then go to the test, you'll get the first rank, and then go and join in this college, you get the first rank, and then go to the company, your life will be great. Right? If there is any GPS for life, it will be better, but then it is not practical, isn't it? Then what is the solution for this? I'm just deviating from this topic. What do you think is the solution then? If you can't learn, or if you don't have this GPS, then you better look at the others' lives, right? And you just see what has happened in their lives, right? And then see if you want to end up like that, then you follow those people, right? So it is kind of looking into the past of others, and then you take the decision, right? Which is like LRU, isn't it? If Optimal is not possible, we are doing the kind of LRU. LRU means we are looking at the many people, how they lived and how their life has ended, and maybe if you follow their traces, maybe our life will also end that way, isn't it? Okay, sorry for deviating. So anyway, this is the concept. Okay, fine.